second grade Base 10 strategy development. This will be an overview of Base 10 strategy, which is an important strategy developed in kindergarten, grade 1, and grade 2 math. Each grade level has their own targeted instruction support to develop Base 10 strategies. In this session, we're going to focus on second grade. Their target is to flexibly use Base 10 strategies within 100. Let's take a look at how this develops. Base 10 strategy is developed in second grade across 4 stages: beginning, developing, approaching, and proficient. In the beginning stage, students are asked to add or subtract multiples of 10 from 2-digit numbers. So in this example, 56 plus 20, our second addend, 20, is a multiple of 10. Students begin by representing these problems using Base 10 blocks, as this concrete representation allows students to develop their understanding of how our Base 10 number system works and what different quantities represent. So in this example, 56, they're seeing that represented as 5 tens and 6 ones, and 20 as 2 tens. This is important as students develop their understanding of quantity, as a common misconception is a number like 56 being represented as 5 ones and 6 ones. We then ask students to describe numbers as blank tens and blank ones. So in this example, counting up the 10 rods, there are 7 tens and 6 ones. Once students are comfortable with the physical, concrete Base 10 blocks, we ask them to connect this to Base 10 drawings. We can see that this drawing matches the structure of the Base 10 blocks laid out above. This is intentional for students to see that connection. The 10 rods up here are represented in these lines down below, and the ones cubes are represented in these circles. Lastly, in the beginning stage, we want students to represent their sums in a written equation. Next, we're going to support students in the developing stage. In the developing stage, students are asked to add with and without composing a new 10. So we have 2 examples here, 12 plus 31, an expression that would not require students to compose a new 10, and 37 plus 25, which would require a new 10. Some of the strategies we support students in using here. The first one is adding tens and then ones. So in the example 12 plus 31, students would identify that 12 as 10 and 2 ones. This can be supported directly with the Base 10 blocks if they have a solid foundation in representing 12 as 1 10 rod and 2 ones. And 31 similarly is broken apart into 30 and 1. And then students add the tens, add the ones, and add them all together. Note we're intentional about how we structure this partial sum strategy because we want it to be really clear for students how they could connect this strategy to the previous representations of both Base 10 blocks and tens and ones drawings. This structure allows students to see 10 plus 30 equaling 40, which matches how they saw their 10 rods being added up earlier. In a standard algorithm where students stack their numbers and carry a 1, you might not see those tens being represented, and it's really important for us to have a strong understanding of what these numbers represent as we're developing Base 10. Another strategy we support students in using is adding on their tens and ones. So we have the same expression here, 12 plus 31. First we add on the 30, the tens, and then we add on the ones. Lastly, we have decomposing an addend to make a 10. So in 37 plus 25, we think about what next multiple of 10 we could get from 37, and we know that adding 3 on would get us to 40. This requires the foundational number sense skill of make a 10. 25 is then broken into 3 and 22. I take that 3 and add it to 37 so I can get to 40, my next nice multiple of 10, and then 40 plus 22 is 62. In all of these strategies, we're looking for students to represent them using equations, as well as Base 10 blocks, Base 10 drawings, and number lines as appropriate. And we're supporting students in seeing the connection between both these strategies and these representations, as they explore new strategies and become more confident in their base 10 understanding. Next, we have our approaching category. In the approaching category, we are doing all the same addition with and without composing a 10 we did in the developing stage, and we're adding on subtraction with and without decomposing a 10. So we have two examples here, 28 minus 11, where we do not need to decompose a 10, and 41 minus 16, where we do need to decompose a 10. Some of the strategies we will encourage students to use in this category. The first is thinking of subtraction as an unknown addend problem. So for 41 minus 16, thinking about that problem as 16 plus what equals 41. Another strategy could be subtracting 10s from the minuend and then the ones. So 41 minus 16, start by subtracting my 10s, so 41 minus 10, then subtract my 1s, and I get the difference. Or subtracting 10s and 10s and 1s and 1s. This would mirror a lot of the base 10 block strategies. 28 minus 11, I could do 20 minus 10, 8 minus 1, and then I have 10 and 7 making 17. Note that some of these strategies work better for problems that involve decomposing, and some work better for problems that don't require decomposing. When needed, we want students to be able to decompose. For example, in this representation, crossing out a tens rod to make a group of 10 ones to then be able to subtract from. Then we move to the proficient category. In base 10 strategy, the move from approaching to proficient doesn't have new strategies for adding or subtracting, but instead we're looking for students' flexibility. So for this expression, 38 minus 11, we want students to choose a strategy that does not require decomposing, since the minuend has a greater quantity in the ones place than the subtrahend does. To teach this skill will require us to have conversations with students about how they select their strategies and have them become comfortable defending and explaining this rationale. So for example, 38 minus 11, a student could select the strategy of subtracting 10s from the minuend and then 1s. So 38 minus 10 first, subtracting my 10s, and then minus 1, subtracting my 1s. We would not want to see students in their base 10 representation crossing out one of those 10s unnecessarily and making 10 more 1s. This would demonstrate that students do not have flexibility of strategy and instead are stuck using the same strategy, even if it isn't the most efficient for these specific numbers in this circumstance that don't actually require decomposing. This flexibility allows students to work with larger numbers later on and shows their flexibility in understanding base 10 numbers and how our numbers are composed and decomposed between the different place values. Thank you so much for watching.